This video is going to cover Module 4, Homework 2, which is complex numbers for MAT 1033 Intermediate Algebra. We're going to simplify radicals that involve imaginary numbers, add, subtract, and multiply complex numbers, and we're going to find the conjugate of complex numbers just like Module 4, Homework 1. So imaginary numbers. So we have what's called I. I represents imaginary numbers. I is equal to the square root of -1. So that is really important. Make sure that you know that I is equal to the square root of -1. It's only the square root and it's only -1. So if I have I squared, so if I know I is the square root of -1, if I have the square root of -1 squared, we notice that square root and squared cancel each other out, and I'm just left with -1. So I squared equals -1. Those two things, very important. We're going to use those throughout this course and throughout this module. So it says simplify the square root of -144. So I can break up -144 because it's a square root into -1 times 144. So I know that the square root of -1 is I. And I know the square root of 144 is 12. So the square root of -144 will give me 12i. The i's written second, 12i. So notice that's different than the negative being out front. This is negative, like a -1 times the square root of 144. 144. So now the square root of 144 is 12, so I have -1 times 12, which will give me -12 as my final answer. So two similar problems, but worked out differently due to the placement of the negative. So the next one I have the square root of -7. So I can't break up 7, but I can break this up into -1 times 7. So the square root of -1 we know is I. Like we said before, 7 cannot be broken up or no pairs can come out or anything like that. So I have I coming out and that 7's left underneath the radical. So my final answer is I square roots of 7. Next example, the square root of -3 times the square root of -6. They are both square roots, so I can write it underneath the same square root. So square root of -3 times -6. So notice -3 times -6 will give me +18. I can then break up 18 into, let's do 2 times 9. 2 cannot be broken up, so it gets circled. I can break up 9 into 3 times 3. 3 cannot be circled, so cannot be broken up, so they get circled. So underneath the radical, I really have 2 times 3 times 3, because 2 times 3 times 3 is 18. It's a square root. I'm looking for 2 of a kind. So I have 2 3's that are coming outside the radical. That 2's by itself, so it's going to stay underneath the radical to my final answer of 3 square root of 2. So definition, a complex number is one that can be written in the form a plus bi, where a and b are real numbers. So that's talking about a complex number. Complex number is one that can be written in the form a plus bi, where a and b are just some real numbers. Next page. So it says, what is the imaginary part? What is the real part? All that good stuff. So we said that a complex number is going to be a plus bi. A plus bi. So we know that I is imaginary. That's what makes it imaginary. So the imaginary part is going to be my bi. because that I makes it imaginary. And the real part is just the A. It's just some number out front, no I, so it's going to be real. So it says a complex number is real if, well, it's real if there's no imaginary part. So if there's no imaginary part, if there's no imaginary part, B must be 0. There's no B term. And then it asks us, what is the conjugate of A plus BI? Remember, the conjugate is just changing this middle sign. So instead of A plus BI, we're going to have A minus BI. And we can use that for rationalizing denominators a little bit later. All right, so going down to our next question, it says add 3 minus 4i plus 8 plus 3i. Notice there's nothing outside of this set of parentheses to distribute. There is a positive 1 outside of this set of parentheses to distribute, but we know we multiply by positive 1, it's just going to stay the same. So we have 3 minus 4i, positive 1 times 8 is just positive 8, positive 1 times 3i is just 3i. So now we're left with this. So we're going to combine like terms. So my real numbers, I have 3 and I have 8. So that'll give me 11. And then my imaginary parts, I have negative 4i plus 3i. So that'll give me negative 1i. Just like a variable or like an x or something. I don't have to write the 1 in front of I. I know that there's one I there. And the negative's telling me that it's negative. So that'll be my final answer. Same concept we added, now we're going to subtract. So there's nothing out front of this first set of parentheses to distribute, but there is, very important, do not forget this part, a negative out front of the second set of parentheses to distribute. So we're left with 7 minus 9i. Negative times 8 will give me negative 8. Negative times a negative will be a positive 3i. And then again, combining like terms. So if I have 7 minus 8 will give me negative 1. And then I have negative 9i plus 3i. That'll give me negative 6i. And that'll give me my final answer. So we added, we subtracted, now we're going to multiply. So I have 8i times 2 minus 3i, just like I would with any other multiplication, just like if it was 8x times 2 minus 3x. All you would do is distribute, same concept. So 8i times 2 will give me 16i. 8i times negative 3i will give me a negative 24. I have I times I, so I have I squared. But we said earlier that I squared equals negative 1. So I can replace that I squared with a negative 1. So I have 16 minus 24 times negative 1. Negative 24 times negative 1 will give me a positive 24. So I'm left with 16i plus 24. Last but not least, usually write it in A plus BI. So that means the I, the imaginary part, is second. So I'm going to flip this around and say 24 plus 16i. So that way it's in the correct A plus BI form, where it's our real number plus or minus our imaginary number. So in this case, it's 24 plus 16i. So next example, I have the square root of 6 plus 2i times the square root of 6 minus 2i. So notice these are conjugates. They're the same thing. We just have different middle signs. So I have a plus sign and a minus. So we're going to distribute. So the square root of 6 times the square root of 6. So I have the square root of 6 twice. The square root of 6 squared. I have the square root of 6 times negative 2i. So I have minus 2i's outside of the radical. It's not underneath the radical, so it's going to go up front. That square root of 6 is going to stay underneath the radical. Now distributing my positive 2i. So positive 2i times the square root of 6. So plus 2i out front of the radical, and then square root of 6. Last but not least, I have 2i times negative 2i. So 2 times negative 2 will give me negative 4. I times I will give me I squared. So now we distributed, so now I can go through and we can simplify. So square root and squared cancel each other out. Just left with 6. Negative 2i square root of 6 plus 2i square root of 6 cancel out. And then I have minus 4 times I squared. We said that I squared was negative 1. So instead of that I squared, I can write negative 4 times negative 1, which will give me a positive 4. And 6 plus 4 will give me 10 as my final answer. So all that crazy mess just left me with 10 as my final answer. All right, a few more examples for this section. The first one is 6 minus 4i squared. So just like we would with the polynomial, we would have 6 minus 4i twice. So I need to write it out twice. Very important. You must write it out twice. Must write it out twice. And then we're going to distribute. So I have my 6 times my 6 will give me 36. I then have 6 times negative 4i. So 6 times negative 4 will give me negative 24. Then I have my I. Now I have to distribute my negative 4i. So negative 4i times 6. Another negative 24i. Negative 4i times negative 4i. Negative 4 times negative 4 will give me a positive 16. I have I times I, so that'll give me I squared. All right, so if we notice, I have negative 24i minus 24i, so combining like terms, I have 36 minus 48i. Just like if it was negative 24x minus 24x, I'd be having negative 48x. In this case, it's I. And then I have I squared. I know I squared is negative 1. So instead of I squared, I can just write negative 1. That'll leave me with 36 minus 48i minus 16. One more time to combine my like terms. 36 minus 16 will give me positive 20. Minus 48i. Final answer. All right, 2 more examples. Next one, it says simplify 8 plus the square root of negative 28 over 2. So I notice, first thing, that I have a radical in there that looks like it could be simplified. So I'm going to simplify my radical first. So the square root of negative 28. Because there's a negative underneath the square root, I can rewrite it as negative 1 times 28. And then I can go ahead and break up my 28. So let's say 2 times 14. 2 cannot be broken up, so it gets circled. 14 is 2 and 7. Again with the 2, 7, same thing. It cannot be broken up, so it gets circled. So underneath my radical, I really have the square root of negative 1 times 2 and times a 7. If you multiply that all together, it'll still give you negative 28. We just broke it up so that way we can take out everything we need to. So I have the square root of negative 1. We know is I. It's square root, so I'm looking for 2 of a kind. So these 2 2's are coming out. And that 7's left underneath the radical. So the square root of negative 28 simplifies to 2i square root of 7. 2i square root of 7. So up here I can rewrite it and say, okay, I have 8 plus, instead of the square root of negative 28, I know the square root of negative 28 is 2i plus 7. 2i squared roots of 7, sorry, all over 2. Notice it's all over 2, so it's all being divided by 2. So my 8 divided by 2 and my 2i squared roots of 7 divided by 2. To simplify this, I'm going to write them each as separate fractions. Simplifying 8 divided by 2 will give me 4. I have 2 over 2's cancel each other out. So plus I square root of 7. Final answer. Last one. Simplifying 1 plus 2i over 3 minus I. So notice, this I is the same thing as square root of negative 1. So there's a square root in the denominator. So we have to rationalize the denominator. So we need to get rid of the i's in the denominator, because we know I is really a radical. It's the square root of negative 1. So just like we would before, we're going to multiply the top and the bottom by the conjugate of the denominator. So the denominator is 3 minus I. So our conjugate will be 3 plus I. We do to the bottom, have to do to the top. And I have to distribute. These are all like little groups, little families, so they all need their own set of parentheses, so I can distribute everything. So 1 times 3, 1 times I, 2i times 3, 2i times I will give me 2, and then I times I will give me I squared. Which that can be simplified. I have I plus 6i, so that'll give me 3 plus 7i, plus 2, we know the square, I squared is the same thing as writing negative 1. All right, I'll leave that, I'll come back, finish simplifying that. Let's do the bottom while we're on this row. So same concept, distributing. So 3 times 3 will give me 9. 3 times I will give me plus 3i. Negative I times positive 3 will give me negative 3i. And negative I times positive I. So negative times a positive will give me a negative. I times I will give me I squared. Because it's the conjugate, we know we did it right because I have plus 3i minus 3i. They cancel each other out. Left with 9 minus I squared, we said was negative 1. So let's finish simplifying this. So we're left with 3 plus 7i minus 2. 2 times negative 1 will give me a negative 2. All over 9. Negative times a negative will be a positive 1. Three minus 2 will give me, combining like terms, 1 plus 7i all over 9 plus 1 will give me 10. So notice if we were to split this up just like we did the 8 up here, I'd have 1 over 10 plus 7i over 10. That's okay, same thing, but nothing simplifies. So either way you're good. My math lab will probably like this one better, but they are both correct. So that is all for Module 4, Homework 2 notes for MAT 1033 Intermediate Algebra.